your group will be testing the pH, temperature, and current of the river. So you have quite a few little tests to run while you're here at the river and not a lot of time to waste. The first thing that you will have done is make sure that you've calibrated your pH meter. pH is going to look at the acidity or the basicness of the water, and that can indicate whether or not chemical pollutants are being placed in the water or what kind of stream bed the water is running through. For example, streams that run through limestone riverbeds tend to be more basic than acidic, whereas streams that carry a lot of leaf litter, such as oak leaves and things like that, tend to be more acidic. And that can determine what kind of life can live in the river. So one of the things you're going to look at is pH. The other thing you're going to do is you're going to collect data on the temperature of the river. You might want to break up your group into some people going ahead and collecting the temperature while other members of your group collect the pH. The temperature looks for any fluctuation in temperature from one area to the next. So you're going to have to travel to take your temperature of the stream and see if there's any difference from point A to point B. The final thing that you're going to do is you're going to collect the current and the discharge of the river. And to do that, you're going to need a meter stick, you're going to need your tape measure or your special measuring rope, and you're going to need approximately 3 oranges along with a stop clock. And the purpose of this is to determine how fast the water is moving and how much load the river's carrying. In other words, how much water is going by. Is it scouring the riverbed? Is it just gently flowing by? And in order to do that, what you'll have to do is time an orange over a distance of 100 feet to determine how fast the current is traveling. And also look at the average depth of the river to determine how much water is flowing by a given point of time. So those are the 3 tests that you're going to be running when you collect your information in temperature, pH, and current. And now let's go down to the river and collect that data. Okay, one of the things that you're going to have to do as part of temperature, pH, and current is get your pH meters ready to actually be used the day of the trip. Now, if you're in a group that's gone first, one of the critical things that you need to do is to make sure that you condition the pH meter. And in order to condition the pH meter, what I've done is I've just put the pH meter, I've taken the cap off the end and put in the pH meter. I have 2 of them here because it's always nice to have 2 to kind of verify and cross-check your results. If you got one that says that the pH is way off the charts and another that says the pH is real low, one says it's real high, there's probably a problem with your pH meters. Maybe the battery's going bad or the pH meter itself is not functioning properly. But if you have 2 pH meters and they're both reading the pH of the water to be the same, you're in pretty good shape. Well, you have to condition the pH meter by putting it in tap water at least 24 hours before you go out to test it. You don't need to turn it on. You just need to make sure that the electrode is in the water. And that's what I've done. I've just put tap water. Do not use deionized water. And one of the things that you'll see is in your pH kit, there is a little manual that kind of explains things to you. Okay? Well, this has been sitting in the water for a couple of days actually now, so it's in pretty good shape as far as being conditioned. But the next thing that you have to do before you go out is you have to calibrate this. It's almost like if you're going to weigh yourself on a scale. If you step on the scale and the scale's reading 10 below 0 to begin with, 10 pounds below 0 to begin with, when you step on the scale, you're not going to get an accurate reading of how much you really weigh. You're going to say, hey, look, I weigh 10 pounds less. You have to set that scale exactly at 0 before you get on it. Well, calibrating the pH meter is exactly the same thing. You have to make sure that it is ready to read the pH of the water, and to do that, you have to take something with a known pH. Like I have here, I have this little packet that has a 7.0 pH. This is, as you recall from reading a little bit about what pH is neutral. Okay? Anything below a 7 is an acidic solution. Anything above a 7 is a more basic solution. So this is set right at 7.0, and it's a buffered solution that will hold its pH. And it has a little notch in it so that you can open it up, and you just tear this open, and then you pour this liquid right into a beaker, okay? And there's my 7.0 pH solution that's ready to use to calibrate this. And you're going to follow the instructions right on here to calibrate it. And it says the first thing you want to do is turn these on. And I have calibrated them earlier, but I'm going to do it again and repeat it for you. So you turn these on, and they have little on-off switches, little kind of buttons that you press there. Got to make sure that one's on. There we go. They're both on. And they're both sitting in this distilled water now. I would hope that they would both read fairly similarly. And this one's reading 7.9 to begin with, and that's reading 8.0. So they're pretty darn close to each other. Okay? But the next thing I'm going to do after they've been on is I'm going to dip them into the chosen buffer, which in this case is a 7. And I'm just going to do it with 1 to show you. And I dip it in there so that the electrode is immersed in that. Okay? And then it says, press the calibrate button. Well, that's easy enough to do. There's a button on there that says CAL for calibrate. And you press that. And it says, the display will flash. And there's a little window in here, and it's flashing right now. And because it's in a 7.0 pH buffer, it's going to probably flash right around that for a while. Okay? As a matter of fact, it's calibrating. It's flashing at 7.0 right now. And it says to let it flash for at least 30 seconds or 30 flashes, okay, because it's flashing about once a second, all right? So I'm going to just sit here and let this do that for about 30 seconds while I let it get kind of adjusted to this pH. And you notice I kind of tilted this down so that the electrode is completely immersed in the pH buffered solution. And they put some green dye in there just so that you can see that it's a solution not to be confused with water. All right? Okay, once it's been in there for 30 seconds, and it's just about been 30 seconds, you're going to press the hold con button, hold/con. That means hold, confirm. And so there's a little button there that says hold, confirm. And I'm going to press that. And it locks it in, and it says, hey, that was the 7.0 solution. All right? Now I have calibrated it, and I can take it back and put it into the tap water. It's important that once it's been calibrated, it's kept moist the whole time until you go out to the river. Okay? You can turn it off, but you need to make sure that it's always kept wet because it's now set, it's now adjusted. You're going to do 2 pH meters and take both of them out to the river and collect your data, both cases, from 2 pH meters so that you can kind of compare and contrast to make sure you're getting accurate data and you don't have to go back to your teacher and say, something's really wrong here because we've got 2 different scores. Or we've only got 1 score and we don't know if that's right or not. So that's how you calibrate these pH meters. It's very simple. You'll do both of them the day of. So when you first come into class on the day of the field trip, you'll calibrate these pH meters. They'll already be conditioned, but they won't be calibrated. Then when you go out to the river, you're going to get accurate data from them. So good luck. Now that we've calibrated the pH meter, we're ready to actually go down by the river, make sure that we're water ready. I got my gloves on, my goggles on, my safety equipment. You do not need waders to collect this information. But what you need to do is you take your calibrated pH meter and make sure it's on and it's set at 7.0. And now you're going to collect the pH in a quiet pool, and that's where I'm at right here down below this ripple. I got a little quiet pool. What I'm going to do is I'm going to stick the pH. You want to collect the pH right at the water side because moving the water and then testing it someplace else can actually change the pH of the stream. And so what I want to do is just take my pH meter, place it in the water, and hold it there for a little bit of time. Give it a chance to adjust and stabilize. And once you see that reading is stabilized, you can go ahead and collect the data and give that to your lab partner who should be standing nearby with their journal in order to write it down. In this particular case, the pH reads 7.2. So I tell my lab partner 7.2. I take it out, put it back into my case, make sure it adjusts back to 7.0 like it just did. And then I go ahead and I take the pH again in the same spot. Let it adjust. And again, it's 7.2 after I let it stabilize. I'm going to do this one more time at this location. Then I'm going to move upstream and take it again in a different spot 3 more times, and then move upstream again about another 100 yards and take it 3 more times. The pH that you report will be the mode pH. That is the pH value that shows up the most. You're not going to take an average of this data. Rather, you're going to just record the mode as the pH of the stream. Remember again, mode is the number that shows up the most frequently. Okay, mode, most. That's the way to remember that. And that's what you need to do for your pH. When you're finished, return the cap and turn the pH meter off, and then put it in a safe place. When you collect your data for temperature of the stream, you're going to have to make several trials. One of the things that you've noticed in reading the stat manual is that you'll collect your data at one particular point, and then you'll collect your data either a mile upstream or a mile downstream from that same point. Now, on the day we go to collect the information, Mr. Matthew or myself will bring our vehicle along so that we can take you from one spot to the next to collect the temperature data. What you're looking for is a change in temperature. Any change in temperature within a mile of the stream would indicate that maybe there's some sort of thermal pollution or something's happening to cause a serious change in the temperature. And that will affect your overall water quality when you run your Q value. So what you'll do is you'll get a thermometer and you're going to look for your temperature in degrees Celsius. This particular thermometer has both Celsius as well as Fahrenheit temperature gradients. So what we'll do is you'll find a spot where you can take the temperature several inches below the surface. You don't just want the surface temperature of the water. You want to get it several inches below the surface, and we'll let it sit there and stabilize for a minimum of 30 seconds to a minute, somewhere in that range. You want to make sure you're getting an accurate reading of what the temperature of the stream is and not the air. One of the problems that some students have is that in order to read the thermometer, they pull the thermometer out of the water and look at it. Well, the moment you pull it out of the water, you're going to be getting the temperature of the water evaporating off of the thermometer or the temperature of the air itself. So if at all possible, angle the thermometer so that you can read it and get your reading while the thermometer is still in the water. In this particular case, the temperature is reading exactly 23 degrees Celsius. So I'll tell that to my lab partner, who will then record it down. I'll wait another 30 seconds to a minute, and I'll again record my temperature in degrees Celsius. And I'll do that for a total of 3 times at this particular site. Then I'll go to my next site, which will be approximately 1 mile away, and I'll repeat this procedure. And I will average the 3 temperatures together to find the average temperature at site A, average the 3 temperatures together to find the average temperature for site B, and find the difference between the two. In a perfectly good situation, there should be very little difference from 1 mile to the next in terms of the stream. Now I look at my temperature again, and once again, it's 23 degrees Celsius. So I know my thermometer is reading stable. It would probably be a good idea to bring more than one thermometer to the site when you test so that you can check the accuracy of the thermometers themselves. And you might want to check the accuracy of the thermometers back in the lab before you go to the site. These are the only sets of data that you need to collect for temperature while you're at the river. So it won't take very long. Just make sure that you get in the vehicle and travel a mile away from site A to site B when you collect this information. And that's all there is to collecting temperature.